Good morning, everyone, and welcome to today's presentation. My name is MG Ekanaik from the Problem Solving Institute in Sri Lanka. I'm excited to have you here. Today, we'll be exploring the different types of data in statistics. We'll start with an overview of what data is, and then look into the various categories and their characteristics. I'm looking forward to sharing some insights and helping you understand this fundamental aspect of statistics. So, let's get started. Today, we're looking at the different types of data in statistics, which can be broadly classified into four main categories. First, we have nominal data. This type of data is all about categories or names, like colors or types of fruits. It doesn't have any intrinsic order or ranking. Next, there's ordinal data, which involves categories that do have a specific order or rank, such as ratings or levels of satisfaction. Moving on, we encounter discrete data. This kind of data involves countable values, like the number of students in a class or the number of cars in a parking lot. Finally, we have continuous data, which can take any value within a range, like height, weight, or temperature. Understanding these categories is fundamental because it helps us choose the right statistical methods for analysis. By classifying data correctly, we ensure our insights are accurate and meaningful, which ties into the overall theme of making informed decisions based on data. Let's take a closer look at the classification of data. When we talk about data classification, we're essentially dividing data into different categories based on certain characteristics. This helps us understand how data behaves, how it can be stored, and how we can protect it. The two main categories are structured and unstructured data. Structured data is highly organized and easy to search, like the information in databases or spreadsheets. Unstructured data, on the other hand, includes things like emails, social media posts, and multimedia files, more free-form and less organized. Understanding these categories is crucial because it influences how we manage, analyze, and secure our data. For example, structured data might be easier to process with traditional tools, whereas unstructured data often requires more advanced techniques like machine learning. So, by classifying data properly, we set the foundation for effective data management strategies, ensuring that we handle all types of data efficiently and securely, which ties back to our overall goal of leveraging data for better decision-making. Let's talk about ordinal data. Ordinal data, or ordinal variables, are a type of data that follow a natural order or ranking. The key feature here is that, unlike some other types, the difference between the data values isn't necessarily determined or meaningful. For example, when you see survey ratings like excellent, good, fair, or poor, these are ordinal because they reflect a ranking or level of satisfaction, but we can't say precisely how much better excellent is compared to good. You'll often find ordinal data in contexts like surveys, finance, economics, or questionnaires where ranking matters. Common examples include rating scales, educational levels, economic status, or ranking systems. These all show a clear order but don't quantify the exact difference between categories. Now, contrasting this with nominal data is a bit different. It's a type of qualitative information used to label variables without assigning any numerical value. Think of it as nomming or categorizing things without implying any order. For example, gender, favorite colors, or types of animals, you can't say one is higher or lower than another, they just categorize. Nominal data is also called the nominal scale. It can't be ordered or measured in a meaningful way, though sometimes it can be a mix of qualitative and quantitative data. For instance, symbols or letters used to label categories, like A, B, C, are nominal. And when we talk about categorical information, it involves variables that describe features such as a person's gender or hometown. These are qualitative or categorical data points, and they're crucial for understanding characteristics rather than quantities. So, to tie it all together, qualitative data, also known as categorical data, helps us classify and describe features or attributes, whether in an ordered way with ordinal data or just labeling with nominal data. Recognizing the difference between these types helps us choose the right analysis methods and interpret our data accurately. Now, let's talk about continuous data. Continuous data is all about measurements that can take on any value within a specific range. Think of things like temperature, pressure, weight, or length. These values are not limited to certain set points. Instead, they can be infinitely precise depending on the measurement tools we use. This makes continuous data very useful when you're dealing with measurements that can vary smoothly and need detailed precision. On the other hand, we have discrete data. Discrete data can only take specific, separate values, meaning you can't have fractions or partial counts in most cases. For example, the number of students in a class or the number of vehicles on the road. These are countable in whole numbers, and you can't really subdivide them meaningfully. Discrete data is often used when you're counting things rather than measuring. Now, let's connect this to the broader theme of quantitative or numerical data. Quantitative data, which is also called numerical data, involves numbers that tell us about the quantity of something. How much, how often, or how many. Height, weight, size, these are all examples. And interestingly, quantitative data can be broken down into these two categories we just discussed, discrete and continuous. Recognizing the difference helps us choose the right way to analyze and interpret the data accurately. Thank you so much for your time and attention. I really appreciate your engagement throughout this presentation. If you take away one key point, I hope it's the importance of applying these ideas to make a meaningful impact. Remember, the concepts we discussed today are all about driving innovation and growth in our field. Your questions and insights are always valuable, so please don't hesitate to reach out. Again, thank you for being here and for your commitment to continuous learning. I look forward to seeing how you all implement these strategies moving forward.